few NPV examples to highlight some things. So we have a project with a cost of capital of 16.2%. Cash flow at time zero is minus 900. Cash flow in 1 year is 1300, and the cash flow in 3 years is negative 200. What's the NPV? Well, if you use the financial calculator, you get the NPV function. 16.2% is the cost of capital, so you put in just 16.2. Then you've got a comma. At time zero, it's negative 900, comma, and bracket. And now it's time to put in the rest of these cash flows. 1300 at time one. What is it at time two? Well, there's nothing given, so 0. Time 3, negative 200. Close the brackets, parentheses, 91.3. So it highlights a couple of things. Number one, C2 was missing, so we assume it's 0. And notice that C3 is negative, so this obviously is not conventional cash flows. We put money in, and then we've got zeros and positive for a while. But then in year 3, it's negative 200. Not a problem. NPV just took the present value. What this was negative 900 plus 1300 over 1.162 plus 0 over 1.162 squared plus negative 200 over 1.162 to the third. That's what the calculator solved for. So again, you can have an interim cash flow of 0, non-conventional cash flows, and that's why this is a nice example. So Patriot Theaters, they're opening a theater that would cost $550,000 today, and then in 1, 2, 3, 4 years, expect 100, 200, 300,000, 100, 200, 300, 400,000. Pretty big cost of capital of 23.4%. So that suggests that this is a risky project because stocks and bonds with the same level of risk as this project have a expected return of 23.4%, which is traditionally quite high for an expected return. Therefore, this appears to be a risky project. So again, we have the expected cash flows. We're going to put in 550 and then expect 1, 2, 3, and 400,000 in 1, 2, 3, and 4 years. Cost of capital 23.4. We can let the calculator do our work. Cost of capital is 23.4, comma, put in 550, comma, then the rest of the cash flows at C1, C2, C3, C4. Hit enter, and notice NPV is negative. What this means is we're putting in $550,000 to make a Boston theater happen. We're creating a theater that's expected to give us 100 in a year, 202, 303, and 404. That has a present value of roughly $545,000. So we put in 550. We get back 1, 2, 3, and 4, but because of the high discount rate, it's really 100 plus 200 over 1.234 plus, 100 over 1.234, 200,000 over 1.234 squared, 300,000 over 1.234 to the third, plus 400,000 over 1.23 to the fourth. That's equal to roughly 545,000. Doesn't make sense to put in 550 to get something back that's worth roughly 545, and so as a result, the NPV is negative, so we would not accept this project. Even though the firm's expecting $1 million over the next 4 years and is putting in just over half of that, the fact that the discount rate is so high that the cash that we're waiting for in 3 years, 4 years, loses a lot of its value. So here we have a situation, Reston Drive-In would cost $500,000 today and is expected to produce cash flows of $75,000 a year forever, with the first cash flow expected in a year. First of these annual cash flows expected in a year. Based on NPV, cost of capital is 12.5. What should the firm do? So what's going on here, I'll solve this, is we have minus 500,000 today plus 75 K forever. So we're putting in 500, and they expect 75 forever and ever and ever. But the first one's in 1 year, and we say, wait a minute, the first of a fixed number of annual cash flows, a first of a fixed set of annual cash flows starts in 1 year, and it goes on forever and ever. And I know that 75,000 forever and ever and ever is just equal to C over R. In this case, that's what the rate is per year, and these cash flows are taking place over the course of a year. And so if one were to go ahead and compute that, this is equal to 75,000 over 0.125, because it's 75, then 75, then 75, then 75, so it's C over R, which is 75,000 over 0.125, which is worth 600,000. So here we have a project where we're putting in 500, expecting, or they are, Patriot Theaters, and they're expecting 75 a year forever and ever, which is equivalent to getting 600 today. So this project has an NPV of 100,000, and we would accept it. What if Patriot Theater has a chance to open a Herndon drive-in? This is a little more expensive, costs $650 today. Cash flows forever. The first is expected in 1 year. It's expected to be 66,000, and then after that, they all grow by 1.5% per year. Again, should they do it based on NPV? So what it really is a case where you're putting in 650,000, and then you expect 66,000 in 1 year, plus 66,000 times 1.015 over 1.125 squared forever and ever and ever. So you got 66,000. After that, they're all expected to grow by 1.5%, and you're discounting every year that it grows by 1.5% by an additional 12.5%. Well, we say, wait a minute, this looks just like a growing perpetuity, where the first cash flow, the one that's due in 1 year, is 66,000. R minus G is 0.125 minus 0.015. So it's actually minus 650 plus 66 is equal to negative 650 plus, and 66,000 divided by 0.11 is equal to 600,000. So here's a project where you put in 650, you create something that's only worth 600, so your NPV is negative, and you reject this project. Who wants to do a project where you put in 650 and then 66 in a year, that grows by 1.5% after that, when the cost of capital is 12.5%, is like creating value of 600,000, creating something worth 600, but you don't want to spend 650 to create something worth 600. There's all the words that lay it out. NPV of negative 50,000. Another example, these are classic Finance 301s. Brocorp has a project that's going to cost 100,000 today, cash flow of 90 in a year, and X in 2 years, cost of capital of 10%, NPV is negative 10. What's X? So again, you know that the NPV, which is negative 10,000, is equal to the present value of the expected cash flows. 100,000 today, 90,000 in 1 year at 10%, plus the mystery cash flow in 2 years at 2%. So we find out that we put in 100,000 today, we expect 81,818, and we have the present value of the mystery cash flow, and the sum of all those is equal to the NPV by definition, which is negative 10,000. So you add the 100,000 to both sides, you subtract the 81,818, and we find out that the present value of the cash flow in times 2 is actually equal to 81,82. And again, that makes sense, is that if we put 100,000 in, and then we get back 81,818 in the first year, plus then 81,82 in the second, it's equal to negative 10,000. So therefore, we know that the present value of the cash flow we need at time 2 is going to equal to 8182, but what's the cash flow that gives it to that? It's equal to this expression, so multiply both sides by 1.1 squared, and you can see you need 9,900. That's the mystery cash flow.